Okay, this was our first turn-in assignment in that packet, and it was just solving linear equations. And what we have to do is we have to recognize what's happening to our variable x in each of these cases. So there's my x. And we're multiplying it by 4 and we're subtracting. Multiplying it by 4 and we're subtracting 9. So we need to undo the subtractions first. So we're going to add 9 to both sides of the equation. Bring down your result. 4x is equal to, well, 15 and 9 is 24. And then we're multiplying x by 4. So to undo multiplication of 4, we divide by 4. And we do that to both sides. And we get x is equal to 6. Moving on to question number 2. Again, here's the variable we're trying to solve for. That's what we want to isolate. We're multiplying it by 6, and we're adding 5. So let's undo the addition first. You undo addition and subtraction first by doing the inverse operation. And when we subtract 5 from both sides, we're going to get 30. Carry down that equal sign, 6x. Now I'm multiplying x by 6, so I need to divide by 6, and I get x is equal to 5. Working my way to question number 3. Question number 3 looks a little bit more interesting because the negative sign that's there. But what I want to do is I want to, again, focus on the subtraction piece first. So I'm going to add 5 to both sides. And I get a negative 9x is equal to 18. Again, our focus is to undo any addition and subtraction first. And then I'm going to divide by what's multiplying x, which in this case is all of a negative 9. These will cancel, leaving you with just 1x, or x, which is what we want, equals 18 divided by 9 is 2, and a positive divided by a negative is negative. So your answer is x equals negative 2. Next one, number 4, up top. All right, we're going to have, this time we have x's on both sides of the equation. Notice we have x's on both sides. So our goal is to try to get the x's together first. All right, so what we want to do is we want to try to bring this x over. Now, we talked about this in class a couple different times. We can either look at this as subtracting x from both sides to get it over together with the other 3. We can't just put them together because they're on opposite sides of the equal sign. So subtract it from both sides, and we're going to get 2x is equal to a negative 6. Well, the other way we talked about it was I want to take this x, I want to move it and combine it with this 3x. Well, when we move it across this equal sign, it changes signs. So it becomes a negative x. And when we put a negative x together with 3x, we get 2x. Once we get down to 2x, to get x by itself, we divide both sides by 2, and we get x equals a negative 3. Now we're going to do the same thing with question number 5. X is on both sides is the equal sign. We got x's on both sides. So we got to isolate the x by getting it on one side of the equal sign. So if you want to, you can bring it across as a negative 5, or you can zero it out on the right hand side by subtracting 5x from both sides. 9x minus 5x is 4x equals 16. Then we're going to divide by 4, and we get x is equal to 4. And then finally, number 6. Again, d's are on both sides. This time something interesting happens if you don't keep track of it. On the right hand side, I'm going to subtract 8d since it's on the other side of the equal sign. Then the 12d. I get 12d minus 8d, that's 4d plus 4 is equal to, don't lose that equation, and 0. 0 is a number, it's good, it's by itself on the right hand side. Now again, my goal is to get d by itself. I'm adding 4 to d, so I'm going to subtract 4. Bring down your result. Notice every time I do something, I draw a line, I draw my line, and I bring down my result. 0 minus 4 is a negative 4. Then I divide by 4, and I'm going to wind up with d is equal to negative 1. And then that was that first turn-in.